Hey Tech Army, what's up? Welcome back to another amazing episode of Tech Timing. So guys, in this amazing episode, we're going to discuss amazing robotic animals you must see. Are you guys excited? Let's get started. So keep up with me till the end, comment right below this video, subscribe if you still haven't, and turn on the post notification for more videos. Number 10. Plurobot the Robot Salamander. The mad robotics at the E. coli Polytechnique Fédérale de Lausanne have produced another biomimetic mechanoid, this one based on the lithe locomotion of the salamander. Plurobot imitates the amphibian's ambulation with its own articulated vertebrae, allowing it to slither along on land or at sea. Number 9. Tombot. The concept of robot dog companions aren't new. Sony already did it 20 years ago with their Abo robot. Problem is that robot dog still looked more like a robot than a dog, making it feel more like a robot toy than an animal companion. The Tombot is looking to change that. Billed as the most realistic robotic emotional support animal, the darn thing looks like an actual pup, with its furry body, flappy ears, and oh so adorable face. Seriously, the only thing that gives it away is the dog's expression doesn't really change in drastic ways, but everything else about its appearance is really enough to convince you that it's a dog. It's uncanny. Number 8. Robot cockroaches. Russian scientists have created what they say is the smallest robot ever, and it comes in the form of a lowly cockroach. The robot walks like an insect and, accepting up-close examination, looks like it too. Unlike real cockroaches though, this small robot could serve humanity in some important and maybe bothersome ways. As one example, robots could slip through the cracks to search for survivors under rubble. Number 7. Eloom. Eloom is a disruptive technology for subsea inspection, maintenance, and repair (IMR). Eloom vehicles are basically self-propelled robot arms whose slender and flexible body can transmit over long distances and carry out IMR in confined spaces not accessible by conventional underwater vehicles. Our vehicles are engineered to live permanently underwater where they can be monitored 24/7 regardless of weather conditions. A continuous IMR capability near the subsea installations without the need for surface vessels means greener, safer, and less costly subsea operations. Number 6. SCAF. A quadruped robot named SCAF-3 driven by gasoline engine is built. The hydraulic flow required by the robot during movement is estimated. An engine speed control strategy is designed based on the fuzzy control. The hardware and software of the hydraulic system controller are designed. Number 5. Spot Boston Dynamics. Boston Dynamics is an American engineering and robotics design company founded in 1992 as a spin-off from the Massachusetts Institute of Technology. Headquartered in Waltham, Massachusetts, Boston Dynamics has been owned by the Hyundai Motor Group since December 2020. Number 4. Festo. Festo has just announced its 2 newest bionic learning network robots. One is a very convincing flying fox, and the other is a walking, tumbling robot inspired by a Saharan spider. Festo calls their bionic flying fox an ultra-lightweight flying object with intelligent kinematics. It's 87 centimeters long with a 228 centimeter wingspan, but it weighs only 580 grams. Flying foxes are the largest bats in the world, and as such, their wings consist of membranes of skin rather than feathers. Mimicking that required some creativity on Festo's part. Number 3. Biohybrid Stingray. The heart cells are taken from 2-day-old rat embryos and grown inside a pattern on a stingray-shaped mold to mimic the muscles of a living ray. The biohybrid's ray muscles move in one direction, and the gold skeleton counters them like a spring. Various light sources are used to move the ray around different obstacles at speeds up to 9 meters per hour. How does the biohybrid ray compare to similar robots? In some ways, it's more advanced than earlier biometric UAV-style jellyfish or flying robot jellyfish because of the biological components. Number 2. Snake robots. Snake robots are a new type of robots known also as serpentine robots. As the name suggests, these robots possess multiple actuated joints, thus multiple degrees of freedom. This gives them superior ability to flex, reach, and approach a huge volume in its workspace with an infinite number of configurations. This redundancy in configurations gives them the technical name hyper-redundant robots. Here, we develop new snake robot designs. Ideally, the future design will consist of 3 degree of freedom stages. Number 1. Batbot Caltech. Bats have long captured the imaginations of scientists and engineers with their unrivaled agility, but their complex wing motions pose significant technological challenges for those seeking to recreate their flight in a robot. The key flight mechanisms of bats now have been recreated with unprecedented fidelity in the Batbot, a self-contained robot bat with soft, articulated wings developed by researchers at Caltech and the University of Illinois at Urbana-Champaign, UIUC. This brings us to the end of our video. I hope you enjoyed it. Hit like if you did, and don't forget to subscribe to our channel so that you don't miss any of our videos in the future. Also, watch the 2 videos that are on your screen now because I'm sure you'll love them. With that, I'll see you in the next video.